continuing on, so remember, tomorrow is a work day. It's also a homework check day, okay? And I am going to go over one calculator thing with you, and then the rest of the time will be yours. Your first test in this class is next Thursday, 9/11. Easy to remember, unfortunately. So your first test is on 9/11 in this class. Okay? Sorry, you guys. Can you guys hear it? I can't hear it. I was trying to listen so I could kind of interpret it, but I'm just going to have to say we can't hear it. But this is happening in everybody's classroom, supposedly. Okay, so I don't know why he's still doing it. Concavity. Oh, my heavens. How many times are we going to talk about concavity? A million. Okay, guys, when I'm teaching, I need you to pay attention, please. And I've referred to points of inflection before, but I haven't really explained it. So here today, we're going to talk about points of inflection. And that's a lot to write, so you'll see POI for short. Oh, this is our drill. I couldn't even hear it. It's a drill, okay, just so you know. We knew it was happening. Don't get upset. You guys, we're going to get to know my TA really well. And because we couldn't even hear it, we're going to hide, okay? So if you want to, everyone's got to get behind that green line. Isn't that great? We can't even hear what the situation is. Slowly but surely get as much in that corner as possible. I know it's hard. And then we'll just stay quiet for a bit. Sorry, get over there before I want you to trip and fall. Don't eat my lunch. Let me put them on so you guys don't trip. Thanks, guys. I know that's annoying in the thing, but we gotta do it, right? Sorry we couldn't hear it, but we do have a recorder in to fix that. If you're watching this video, we're back. So hopefully fast forwarded. Recording that whole time. Thanks, guys. Thanks. All right, guys, let's jump back in. All right. So points of inflection are where concavity changes. Something I will say, guys, is every classroom has that green string, and it's like a force field that comes down and protects you if you're on the other side of it. Just kidding, honestly. I don't know why that is. I guess they're just saying it's the furthest corner. And there's no wrong answer. I want you guys to know that, like, if it were a real situation or even a drill, to be honest, I probably wouldn't say this to my Algebra 1 kids, but you actually can choose. Like, if your class is like, what do you guys think we should do? Or if I'm like, I think we should hide, or I think you can do what you want. You don't have to do what your classmates do or what your teacher does. So just keep that in mind. In a real situation, unfortunately, these are things we have to talk about. You feel like it's better for you to run, you can run, or if you want to hide while we run, you can hide. Like, it's your choice, okay? We knew it was a drill, so I didn't want to run. Okay. Anybody have a question for me about any of that? Okay. All right, so POIs, lazy shortcut, is where concavity changes, all right? And so I'll come back to that in here. So a function f is concave up. Again, I'm just using some abbreviations. Let's get through this. I know we've been using these abbreviations for a while. On an open interval. Guys, open just means that there's arrows on both ends of it. That's all that means. On an interval, if the graph looks like a U or part of a smile. So we are concave up somewhere to about here, right? Somewhere in here is where that POI is, okay? A function f is concave down on an interval if it looks like an upside down U. So somewhere around here, not worry about it too much. We know somewhere in here we have a POI. A function has a point of inflection at C, somewhere in here, let's call it that, on an open interval if the graph changes concavity. So if you remember, when we took that 1-1-1-2 quiz and we had the quiz review the day before, we, in my classes, and maybe this class too, talked about how sometimes it can be hard to figure out where that point is, right? And I kind of showed you if you use a Post-it note and do it like that. Well, the truth is, here's the truth. The truth is you really can't find an actual point of inflection until you get to calculus, okay? So we've been kind of estimating, and I have a new and really easy way to help you figure out what that point is. And it's called the midpoint formula, okay? Yes, back to geometry. Like literally the midpoint between these two we use as an estimate of the POI. So the midpoint formula is real simple. So it's add your x's together. Oh, sorry, that should be a 2. Divide by 2. Add your y's together. Divide by 2. And that gives you the middle point, midpoint. Okay? So taking those 2 points, and it doesn't matter which one is the first x, which one, it makes no difference. Because when you're adding 2 values, it doesn't matter which one comes first, which one comes second. So, guys, you're just literally adding your x. So let's say this. My x value will be -2 plus 3 divided by 2. Add your x's together, divide by 2. So an average. And you'll get 1/2 or 0.5. It doesn't matter. Okay? So the x value of that point we're estimating to be about 1/2. And then the y value of that point would be -6 plus 4. My y values, any order, divided by 2. Okay? So new-ish, easy, right? A way to estimate your point of inflection. It's not always exactly in the middle. It's an estimate. So it's an easy way of estimating. Okay? Any questions? Let's make a connection to what I taught you yesterday. If you remember, one of the things I taught you is that if you know the degree of a polynomial and you subtract one, you get what? If I have a degree 5 and I subtract one, what is that for? 4 is what? What is it? Turning points. Really good. Fun fact, if you subtract another one, that's how many POIs you have. Okay? So you can start with whatever you want. So label the approximate location of each point. I think they mean point of inflection on the graph. And shade concave. We're not going to, you guys get it. But if you have 1, 2, 3 turning points, that means you're going to have 2 points of inflection. Think about it. We're concave up until somewhere around here, in between these 2 points, right? And then we're concave down until somewhere in between these 2 points, right? So if we have 3 turning points, we will have 2 POIs. I don't know if it's, I know this is not good grammar with that apostrophe S, but POIs. So let's make one more connection. What would the degree be of this polynomial? 4. So this would be a degree 4. It is not always 100% this simple, okay? If you, let me say it another way, it's a good generality. If you are a degree 4, you will have at most 3 turning points. And if you have fewer turning points, you'll have fewer POIs, okay? So this connection is always true. If I have 17 turning points, I will have 16 POIs, okay? But there can be a discrepancy between degree and turning points. It will never be more than this number, but it could be less, so at max, okay? So that's just something to think about. I think it comes up on something on College Board later, okay? All right. Moving on. Now, we keep getting asked a whole bunch of questions about graphs. And we're going to answer all of these questions together about this graph. You know, I keep telling you guys, we don't graph a lot in here. We do. There will come days where we have to actually do a graph of something. We really use our graphing calculators to help us with that a lot. This is not a graphing class. But the thing we do a ton of, as you've already seen, is have to pull lots of information off of a graph, okay? And all of the stuff that we've done is here, and all the new stuff is here, and some things we haven't even really talked about. So we're going to answer a bunch of questions together using this table of values. Please don't tune me out. This is really, really good stuff. This is really good review of so many things that I've taught you, pretty much everything up until this point. So I love this example. So really pay attention and ask me if I'm not clear or whatever. So my experience with this problem is this. So here's a table of values, and this is the graph of these points, okay? So these are some of the points of this graph. Trust me, it is worth it for us to take 30 seconds right now and label the points. In other words, like this is -5, 0, and so on. It's going to make answering the questions a lot faster. So I'm just going through here and labeling each of the points that they gave us. So you should be doing this as well. Okay, domain and range. I don't think we've talked about domain and range. Domain is your x values, range is your y values, right? Domain of every polynomial, let me say it differently. A polynomial, the degree of a line, a quadratic, a cubic, a quartic, a quintic, any degree, any of them, your domain is all real numbers. If you have arrows on the ends, whether they're both going up, both going down, or opposite direction, that means you're going to hit every x value from -infinity to infinity. So all polynomials have a domain of all real numbers, also known as negative infinity to infinity. Now the range is going to change, okay? And remember, this is true interval notation, like where you would use brackets or parentheses when appropriate. And we always do interval notation in least to greatest, okay? So looking at our y values, find your lowest point on the graph, and we would go up from there. So our lowest point on the graph is this point. So we would use that y value. The lowest y value is negative 8.1, right? And then it goes up forever. The order matters. It's wrong if you do it in the other direction, okay? Now, what we have to decide is, do we use parentheses or brackets on this? I don't think any of you would debate that you always use parentheses on any infinity symbol. But what about on the negative 8.1? Zoe said bracket. Does anybody disagree with her? Good. She's right. Okay, good job. Yeah, it's a bracket. So let me tell you why some students get confused by this, okay? Maybe you didn't admit it or something if you didn't agree with her. Because what I've seen students think is, because that point is not actually on like the y-axis, they think it shouldn't be included. But what this is saying is, what is the smallest y value that is used to make this graph? Well, this point is part of the graph, and that is this y value. So it is included in the graph. It doesn't mean it has to be on the y-axis, okay? Good? Domain range? Okay. Interval where g of x increases or decreases. In these two situations, you can use I don't know why I did that. You can use parentheses or brackets. This is where it doesn't matter. You can choose parentheses or brackets for increase and decrease. Remember, interval means part of the x-axis. So increasing, I'm increasing here, and I'm increasing here, right? And this is why it's going to make our life so much easier from labeling it. Look, from this to this is this x to this x, right? And I like parentheses, so I'm just using parentheses, but you can use brackets. But you wouldn't mix and match, okay? So in these situations, when I say one or the other, you wouldn't do like, oh, I'm going to use parentheses on the left and bracket on the right, okay? Pick which one you want to use. And then again, from 0.9 to positive infinity. Not because it's going up, because it's going to the right, all right? So it would also be, bless you, 0.9 to infinity, okay? Let me just take that back real quick. If I had used brackets here, so that's an exception to the rule. Of course, you would use parentheses here. I just meant like on this one, you wouldn't use like brackets here, parentheses here. Okay, so this would be perfectly fine because you have to use parentheses here. Okay, so I kind of misspoke. All right, and then we are decreasing here and here, and decreasing left to right. We always read our graph least to greatest, just like we did our y values least to greatest. I meant to say that. So this is from negative infinity. Be careful, we're going up, but we're also going to the left. So that's negative infinity all the way to this x value. Has to be in that order or it's wrong. Okay, it's something we're picky about. And then from this to this, and again, nice job. Pat yourself on the back for labeling. It just makes these parts a little bit easier. Okay, so something that keeps coming up must be pretty important in this class. Good with that? Yeah. Okay, here's the stuff we learned yesterday. Max, mins, relative, absolute. Let's review what we learned yesterday. So we have, let's just maybe, I don't know, we can start, it doesn't matter where we start. We don't have to go in this order. Let's just start with this point. Because if you're a turning point, you're definitely going to get named something, okay? If these were end points, like no arrows, then those would get labeled as something as well, okay? In this case, because there's arrows on the end, we just have to look at our 1, 2, 3 turning points. Those need to get assigned a job, okay? So somebody tell me, what would we call this one? What does it start out as? It's the absolute, what is it? Absolute, which one? Min. It is the absolute lowest point. Here's one of the ways to write it. The y value at x equals 0.9. But remember, anytime we're an absolute minimum or an absolute maximum, you also get put in another category. So it's also going to be a relative. That weird thing in this class that we just say, okay, if you say so. All right, let's look at this point, -4, -4. Anybody? Relative minimum, right, Cody? So it's at the bottom of the concavity, so that means it's a minimum. I don't feel like I explained that really well, so if someone's confused between how is she picking min or max, tell me and I'll do a better job of it. Okay, so remember, if you're a relative min or a relative max, that doesn't make you in reverse and absolute. It's only a one-way street. If you're absolute first, then you get assigned also relative, not the other way around. Okay, and our last point, of course, this is still just a relative minimum, right? We don't have an absolute maximum. You can't if there's arrows going up, because there's always going to be points higher than anything else. So this would be a relative maximum, which would be 0 at x equals -2. Okay, so that kind of recapped what we learned yesterday. Good? How many points of inflection are there? 2. 2 POIs. Why? Because there are 3 turning points on the graph of g of x, if we were really writing it out, but I'm trying to speed this up for you guys. And intervals where we're concave up, intervals where we're concave down. You have to use parentheses for concavity. That's the rule. Which means, let's look at our graph. I'll use a highlighter now. We're concave up to somewhere in here, right? Somewhere in here. And then we're concave up here, somewhere in here. So what I'm gonna do one with you. I'll give you the answer together. We want to know what these two ordered pairs are using our new trick. Those are our POIs, right? Where concavity changes. And I just taught you that if you take the 2 points, doesn't matter what order, and you do the midpoint, you can get a quick and easy estimate of your POI. Okay? So add your x's, divide by 2. Add your y's, divide by 2. So I know I did that really fast, but it's midpoint. So this POI would be -3, -2. And I'm just going to give you this one because we don't need to do that formula twice. This is decimally, so 0.55, comma, -4.05. Just trust me, I did the same formula with those 2 points, and I got -0.55, -4.05. Okay? All right. Where are we concave up? Interval, x-axis, have to use parentheses. So this section right here would be all the way to the left, which is -infinity, to this x value, right? Interval, x values. -infinity to -3. We're also concave up, look at your graph, from that x value I gave you to what? What would come after that? Infinity. Yep. As we go up, we go right forever. So again, these are estimates, but they're good educated estimates. And we're concave down in just this little section in here. So from this point's x to this point's x. So -3 to -0.55. Okay. So that's a really good tying together lots and lots of stuff. One last thing to talk about. I know it's taking a long time because of we still have a lot of time. The bell doesn't ring till 9:41. And this last example won't take very long, and you'll have a lot of time to work on your homework. But again, tomorrow is a work day, so that's good. Good here? Okay, last thing. Another graph. And this is, again, this is reviewing some things that we've talked about before. I'm going to read this first question to you, and I'm going to tell you what I always review my notes before I teach, and I was reviewing this, and I was like, oh, my key is wrong from last year. I got that wrong. And then I realized, no, I just read it wrong. And so did my second period. So take a second and let's really think about this before you answer it. This is where we get tricked, and you don't want to get tricked. Is the rate of change of P of X, this is P of X, increasing or decreasing at point A? Besides Zoe, somebody tell me what you think. Raise your hand if you think it's increasing. No, I don't want you. Raise your hand if it's decreasing. Okay, Jacoby, why do you say decreasing? It's concave down. Yeah, so I did the same as probably what you guys did with the increasing. And this is so important. We're going back to, this is why I hung this on my wall so it was an easy reach. Remember, anytime you pair rate of change, which is slope, with increasing or decreasing, we're talking about concavity. We've got to remember that. My brain did probably what yours did. You looked at A and saw rate of change. Oh, the graph is increasing here. It is. The graph is. But the slope is decreasing because it's part of a concave down part of the graph. You can say the slope, the rate of change is positive, okay? It's positive, but the rate of change is not increasing, okay? So think back to concavity when you pair the words decreasing and increasing with rate of change, okay? So let's write this real quick. At point A, I'm going to just put A rock for short, of P of X is decreasing, abbreviating, because the graph is, I should have said the graph of P of X, I should have just said P of X to make it shorter, is concave down at point A. So internalize that, guys, because that's something that keeps popping up, and I'm still seeing a lot of mistakes. So really, 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 really think about that. Okay, what is the rate of change, the slope of P of X at point B? This is going back to tangent lines at that point. What is the slope of the tangent line at point B? Yeah, this is a horizontal line. The slope is 0. Guess what? That's the rate of change at every turning point on a graph, okay? Any turning point would have a tangent line that's horizontal, so you could say the slope is 0. Okay, we're not going to write anything else. Could point C be considered a point of inflection? What say you? Yeah, that's a good guess, right? That's a good spot. Yes. Point C is between two turning points. Is the rate of change at point D positive or negative? Is the rate of change positive or negative? Positive. It's increasing. The graph is increasing, okay? The rate of change is increasing because it's concave up, but it asks positive or negative. That's when you're just looking at, are we rising, are we falling? Positive graph of, so I'm just trying to really get us in the habit of writing good sentences, is increasing at point D. Okay? So thank you for staying with me with all the stuff going on. That is it. Page 49. That does not say all, that says A11. I tried to make ones, but they're not really cute ones. A11. Okay. There's a little bit of a line right now. Someone's already out, and then there's one person ahead of you. So 19 and 20. Anybody have any ideas about my YouTube video? Do any of you know what are you looking for, Toby? Oh, thank you.
So, what is it's going to?
I don't know. I usually have to just mess with, like, this is my little sound thing. And my volume is up on my smart board, but nothing on the tab. And I keep cord that's not coming in. I'm wondering if it's got that green color.
Yeah.
Do you think that's it? Oh, also my sound was muted on my phone.
Which one? Warning
It's
signs.
coming out. Even this is better than silence. You can put on closed. I felt like it had to do with, like, see how it's on microphone right there? So I clicked on it and this is what popped
It
up.
shouldn't be on the microphone. It should be devices, and then the input, other devices. Any idea? Dell. You have to do USB 3. Oh, yeah.
Oh, click on now.
This
Yeah, that one.
headphones up. It's
I
a
don't know.
keyboard.
It's okay. As long as I can play it through here. But I know. My cord situation is insanity.
Yeah, no, I could
It's
probably.
bad.
You might have taken a video so I connected it.
This is the computer speakers. Do you know, like, earbuds, headphones, anything like that?
Let me see if I.
Okay, so you probably shouldn't have this.
You don't show him that, do you?
No. I'm trying to figure out where the stuff's going. Yeah, I was trying to figure out what goes where.